And welcome everybody to the next episode of YugabyteDB Friday Tech Talks for engineers from engineers. My name is Kannan Muthakkaruppan. I'm one of the co-founders at Yugabyte, and my pleasure to welcome Frits Hoogland, a developer advocate at Yugabyte based out of Netherlands, who's going to talk about some very interesting work that he's been up to. So Frits, take it away. Feel free to introduce yourself and then get right into the topic.
Yeah, we are live, right? Because in my other screen, I don't see anything live, but I'm not sure. So let me introduce myself. I'm Frits Hoogland. I'm from the Netherlands. So I talk a bit funny English in that sense, but don't we all? And indeed, I've been working on a tool which is heavily used today in Yugabyte, which is called YFTT. And YFTT is essentially...
looks like some folks are saying they're not able to hear the audio. Okay, but then others are saying they can hear. So okay, let's continue.
Okay. So the first obvious question when introducing YFTT is, what is YFTT? And YFTT is a tool for the Yugabyte database to try to extract all available information, all operational data from a YugabyteDB cluster. So it's important to say that there is no actual client data extracted from a YugabyteDB cluster. It's all metadata which is extracted in order to diagnose performance and operational issues. So that is the core thing which YFTT does, or what YFTT does. And the next question then would be, okay, but we've got a lot of tooling around it. Why would I need it? Well, it is important to get all the available stats and facts that you can from a cluster if you're investigating an issue, or if you're just wondering if everything is running all right. And the way it's performed is that the tool assumes as little as possible, and it just tries to get all the data. So if something changes or you install a new version of the database, it will just pick up all the new data. You shouldn't require a new version of YFTT to match the new version of the YugabyteDB cluster. And pretty much in the same idea as a tool on which I've worked earlier, is the aim is to be a one-stop information source. So you capture the data, and once you've got a data which is stored in an open format, everything that you can capture is there, so that if you're investigating something or you send the information in it to someone else, that person then also has all the information to look into an issue or to look into a performance issue. It's created in order to be as open and as simple as possible, which means that we've used the CSV file format, so it's just readable text. Everything is completely readable, which is also very handy if you have security folks which are concerned that you're sending out something which might be proprietary or secret. You can read all the files, everybody can look into it and see what is sent. So it's completely open. And because it's plain CSV files, what you can do if your cluster doesn't have any internet access, you can simply zip it up, put it on a USB stick or on a Bastion host, if you've got something like that in your environment, and then send it from there. So even systems which do not have direct internet access, therefore can be investigated. And what I do find really important, and what I sometimes see go wrong in general, I should say, and what I've also seen in the past, is it allows for the collection of facts. So if you're investigating something, you can look back and see whether, if you have an hypothesis about what might be wrong or what might be happening, you can look into the facts and see if that is actually happening. So you can base your assumptions and investigations on facts and not on advice or guesses. I see a lot of people guessing and just apply things which they've read somewhere on the internet. And the whole idea of YBStats is that isn't necessary. You can look what is happening at this moment and then go from there. Also, if you try to do capacity calculations and these, because all the performance facts are also captured, you can get mathematical exact facts about what happened and use these for calculations. And another thing, because YBStats works based on snapshots, if you're investigating something and you have a reproducible case for it, what you can do is take a snapshot of the good situation, which is the before situation, then perform whatever you're investigating, and then perform a snapshot again, which is the after situation. What is really important then is that you can go back to the first snapshot and look what the before situation was and investigate that and see what the differences are for the after situation. And that is something which is really important if you're investigating something. Having said that, of course, no tool can just do everything that you want to do. And I do think that anything which you are doing should be totally focused on the primary task that it should do. There are actually a lot of things that YBStats doesn't do. And we've got a management suite, which is part of the paid offering of YugabyteDB, which is called YugabyteDB Anywhere. The YugabyteDB Anywhere has a metrics component, which can show you graphs of certain statistics. And because YBStats works based upon a static snapshot of a certain point in time, and then use another point in time, a snapshot of another point in time, to see what the differences are, obviously you cannot see how if the change was, if you take the average, if this change was always the average, or whether something was really busy for a certain amount of time and then really idle for the remainder of the time. So it is not, you cannot see all these details. Another thing which might be not handy or handy, depending on where you come from, is the purpose of YBStats is to take the statistics as they are available and show them to you. It doesn't interpret data and provide you a whole guided course of saying, okay, you've got this data and then you should do this and that to solve what you want to do. YBStats doesn't do that. It just shows you the facts as they are measured. Another really important thing is, at this moment, YBStats is not part of a default YugabyteDB install. We're working on that. So at the moment, if you need YBStats, you should manually install it, probably on one of the nodes, to be at the same in the same environment as the endpoints are, which provides the metrics which YBStats needs. One of the common questions that we got about YBStats is, does it have a performance impact? If I'm running it, does my database slow down because it gets a lot of facts? It reads a lot of facts from the database. Well, the answer is it indeed reads a lot of facts from the database. It reads everything it can get, but it reads it from the endpoints which are explicitly meant to provide you this data, which are different endpoints than the data, than which the databases, which is Cassandra and YSQL Postgres endpoints are using. So it doesn't obstruct anything directly. Having said that, in certain, there are some cases which have been reported, which are exceptional, which is if there is an enormous amount of use, where so a lot of threads are active, which greatly outnumber the amount of available CPUs, that getting the threads overview, which actually all provide a backtrace of each individual thread, which potentially could cause some slight interruptions, and therefore there is a distinct switch, which is called -- disable threads, to stop this from being collected. But that should be and is an exceptional case. In principle, it doesn't really provide anything which is noticeable in the performance. Of course, if you run it from the node itself, which is in a lot of cases is the most logical point to run YBstats, it will take some CPU because any process that runs needs CPU slices to run on. However, the impact of that is insignificant. If you install YBstats, it's explicitly created that in a way that you need to specify the endpoints, IP addresses, which is pretty much like the YBadmin tool needs it. However, if you specify it one time, it will store it in the current working directory in a file called .env. And after that, if you invoke YBstats again, it will read from that file and read that endpoint data. So it's essentially a one-time setup in a directory, and then it will read the .env file and it will fetch the data from that. So you don't need to specify an IP address and a port number, because for Yugabyte, especially if you have clusters with multiple nodes with more than a few nodes, this can get quite a lot if you need to specify each IP address with a specific port number. So it's created that you specify all the IP addresses, and separate from that, you specify the port numbers, and it will automatically probe the ports for the available data. And if that data is not available at that port, it will just skip it. And that is what is found to be the most easy way to do it. If you're using it, it has two modes. There is the ad hoc mode, which is essentially that you just run it and it will give you the performance data back if you press enter, so you can do little investigations yourself. This doesn't store all the other data, which are, for example, the log files of the master and tablet servers. And there is the snapshot mode, and the snapshot mode is the mode which tries to truly capture everything that is available. And that will store it in CSV files. So the first option doesn't leave anything. It will just provide it on the screen, and you can base your investigation on that. And that is what I use myself a lot if I'm looking into specific issues, because I just want to do quick tests and do not want to end up with an enormous amount of snapshots, which most of them have nothing in it. And there is the snapshot mode, and the snapshot mode is more, if you are in an environment, you don't know exactly what is going on, you snapshot it, you make sure that whatever you're investigating is then happening, and you snapshot it again, so you've got a difference between the two. There are also some of our clients and some of our teams are using it in a Chrome tab mode, which is using Chrome tab to take a snapshot every hour and then automatically store it. So if something is happening, they can essentially go back in time for each hour and look what the state of the cluster was at that point in time. So that is another option. But for myself, I'm not using it in that way. Let me give a little demo so you can get an idea of it. So I will stop my presentation. Is my screen visible to everyone?
Yes, Frits, screen is visible.
Okay.
I don't know if you want to make the font size a little bigger, but if you need the width, then it's fine. Yeah.
Yeah.
Sounds good.
Yeah, the width might be a bit of an issue because YBstats captures a lot of data, and that's the name of it. This is a fairly big font size for me, but the first thing which is handy, if you've installed YBstats via the RPM install, it will install YBstats in user local bin, which is in the default path of a Linux shell. So you can then just execute YBstats. And one helpful thing is YBstats --help. And with --help, all the available options are printed, like pretty much any other tool. One of the things that you can do is the first time install, which I've talked about. If you need to install it, if you run it for the first time, then specifying the hosts in this way as a comma separate line and say snapshot in this case, and I'm now requesting it to be parallel. It will then, now it's set up, and it will create a snapshot already. This information is stored in a file called .env, and .env will say YBStats hosts is the comma-separated IP addresses list, and the amount of parallelism is stored. And I can now say YBStats this snapshot again, and I'll take another snapshot, which is snapshot number 1. Just to show and give you an idea what a snapshot means for performance, I can get a snapshot, wonders of live demo, a snapshot diff, and show the performance difference between snapshot 0 and snapshot 1. Please mind, I didn't do anything. I just took a snapshot, waited a little bit, and then took another snapshot. And what you'll see is that there is a lot of stuff running on the screen. This is totally the focus. But the question you might have is, if I'm not doing anything, how come there is such an amount of data visible? Well, the point is that this is a cluster, and a cluster, well, even a non-cluster database is doing a lot of things in the background just to make sure what it's doing. And in the case of the Yugabyte database, in order to perform cluster communication and perform raft communication. So it does things in the background, and this is all this data for which it's is what is happening in the background. And quite importantly, what you will see is things like heartbeats and other things. So even an idle snapshot will show you a lot of data. So if you want to do something,
and Frits, and the parallel, what was the parallel option do? Perhaps you could help clarify what that does.
Because if you take a snapshot, it actually tries to get quite some things. It is handy to perform performing the snapshots on the different hosts in the cluster in parallel, and that is what it does. So for each node, it will get the different, for each IP address specified, it will get all the data in parallel.
So even if I have a 30-node cluster, if I say parallelism is 4, then that's kind of the max number of tasks running in parallel to get data from the host. Is that a fair statement?
Yes, well, the tool will limit the amount of parallelism to the amount of cores in the system to not overload your own local system doing it, but it will try to use as much in parallel as possible in order with the idea to shorten the time to obtain data. That is the idea. Then what another thing which is handy to look at, because we now got snapshots, is, for example, we got this thing which are masters, which are the controlling entities in our cluster. And what we can do is YBStats print masters, and then take a snapshot. And I've got snapshot 0 and snapshot 1, which is what we just saw with snapshot diff. And what it does, and this might seem confusing, but it's absolutely the point and vitally important that it does this. It fetches the data from each master. And if you look here at the role, you can see that the node with the RPC address ending on 206 is actually the master leader, and the other one are the master followers. So this node, 195, is a follower node, which understands that 206 is the leader. If we then go to 206, which is this one, also says that it's the leader. So what we can determine from this view is who is the leader, but also that all the leaders agree identically on how on who the leader is and how that looks like. And that is the important part of it. Another thing which we can see, which is rather simple but really important at times, is versions. the YBStats tool obtains the versions from all the endpoints. So in this case, we can see we've got 3 different nodes, 3 IP addresses, and the nodes end with 9,000 to 7,000, which is the tablet server and the master. And the version on all these distinct endpoints is identical in this case, so that's good. Again, what this allows you to do is, if you're investigating a cluster and you've just upgraded, this allows you to see whether all the nodes actually upgraded or not.
That's great, yeah.
Another thing which might be handy to look at, and that's especially if you're investigating an issue or if you set G-flags, is looking at G-flags. I should warn you, we've got a lot of G-flags for all the different servers, and I print them out per server, but you can use the flag stat name match to specify a regular expression and say, for example, well, let's take a P module, for example, just as an example. And in this case, we can see that for all the different endpoints which have G flags, we can see that the P module G flag is not set. But I think most of the people here can understand that that this is a really handy feature to very quickly determine whether a G flag is set. And secondly, if it's set for all the nodes, which is really important.
Like, could we check something like db_block? I'm just curious, like, suppose we wanted to check if the block cache size, yeah, okay, let's try that.
So db block, these are the cache sizes for all the different endpoints, which is 7,000, 9,000, 1,200.
Got it. Thank you. So it's a 32K block size. Sounds good.
Yeah, yeah. For all the different nodes in this case. There are many more things which we can show, but there is only so much that we can do. And let me go to the next slide, which is actually the last slide, but we're already also approaching the 30 minutes for the tech talk. A typical use case of using YBStats is to investigate something that is happening. And one of the things which you can do, for example, is run something in YSQL and see what the impact of that is. There is an option with YBStats. So let me get this screen again, which is called a snapshot command. And in this case, I put a comment in which is YSQL bench. So I create a snapshot which says snapshot number 2 and a comment of YSQL bench. And then I execute 2 lines, one line setting an environment variable. And the other line is running YSQL bench, which inserts some tables. Well, it first tries to drop tables, but the tables do not exist. Then it creates tables. And once it's done creating tables, it will insert some data. So that is now happening. And now, after that's done, and that should be done by now, let's create a snapshot again, saying YSQL bench. So now I've got a snapshot with a certain command just to identify this investigation. I've done something, and then I create a snapshot again. And now I can use YBStats snapshot div, and it will list the snapshots. So the first 2 are the empty snapshots, which I've just shown. And I've got 2 snapshots, which have the command YSQL bench. So I can use snapshot number 2 and 3. And this is all the performance data which happens when I run this. This is too much to look at, obviously. So can use hostname match to use a port number to filter on, and 13,000 is our YSQL port number. So if I use this and then use the snapshots, this is the YSQL data, and the YSQL data is divided between the PGA data, and the PGA data itself is divided between the 3 hosts, the 3 YSQL hosts which I have in my small cluster, and each host has a number of statistics. This allows me to see these statistics, and for these statistics, this requires some explanation. Please mind that all these statistics and the exact definition of the columns is in the README in the GitHub repository for YSQL, for YBStats. But the first column is the number of executions. The second two columns are the times. The first time is the average time over 24, in this case, catalog cache misses. And this time is the total time. Well, in the case of a delete, it took approximately 1 millisecond for one delete. Well, and then obviously the average time is identical. And this column is the number of rows. Well, if you look here, then we see a couple of things. We see the statements, which are the statements that are part of the of running YSQL bench. And I see some other statements on other nodes because I executed YSQL bench on a single YSQL instance. That's 156. The other two also got some statements, but these statements are verified statements from platform to validate that a YSQL endpoint is available for insertions and deletions. So these should not, that is what we're not looking at. And what we now can see is that YSQL bench executed create statements and insert statements for a couple of tables. And YSQL bench tellers had 50 executions for 50 rows, and YSQL bench accounts had a lower number than the actual number of rows, because we could see, well, when I run YSQL bench, that it inserted thousands of rows, but that is because the copy command is a batch command, so it cannot count the number of rows, because if it would do, then it would not be batching, but an individual row execution. And the really important part here is that you can see the amount of times. So this is a first step in an investigation into probably slowness for something, or a statement which isn't executing as fast as you think. You can look at other statements which have been executed in that time, provided they are captured by pggate. And actually these commands are not coming from pggate, but these are coming from pgstat statements, which is a standard Postgres facility for capturing statements. And there is a limit to how many statements pgstat statements can execute. And it should be really strongly considered that pgstat statements only captures the execution time of the statement. And there are some other times, like for example, parsing and planning, which are also part of execution. But that is what that is what pgstat statement provides.
So Frits, presumably this tool can also help in identifying if, say, the traffic coming to different nodes in a Yugabyte cluster is queued or fairly uniform, because it has the host level breakdown.
Yeah.
And one question, like if you're just below the highlighted section, it says 50 rows for the insert statement, right?
Yeah.
But like the third or fourth line on this terminal says insert statement, number of insert statements is 1. Is that simply because the single statement itself was inserting 50 rows, like using the multi-row syntax?
Yes. This statement was executed 50 times and executed a single row per insert statement, and this did not use the multi-values option.
But then if you look at the third line on the screen, the insert statement on the very top of this page, but there it says we executed an insert statement only once.
Yes, but that is this insert statement is node 195, and 195 got the single row insert statement.
Got it. Okay, yeah, the host name has changed here.
Yeah.
Thank you.
Yeah. So, and what this very nicely does, and what I urge a lot of people to do, is think in the different layers that Yugabyte has. And it allows you to look into, in this case, this is the YSQL layer. And then going from the YSQL layer, if we take a host name match of 9,000 for these, then we can look at the PG gate layer, for example, the PG client service layer, which is the Postgres handling layer in the tablet server, and then the actual tablet server layer, which is one level deeper in executing actually tablet server functions. And in this way, you can break down what is happening, and this data shows you the amount of times that a tablet server service read was executed, and the amount per second, and the average time. In this case, it's microseconds, and the total amount of microseconds was 196 for this specific statistic, and divided by the number of executions, that's 1998 microseconds in this case. And in this way, you can break down and very much focus on specific parts which have a statistic in the Yugabyte database. So
by the way, Frits, there was a question like, do you have a UI dashboard that uses Grafana or something similar? If so, could you give us a demo? I know we won't have time for that, but and there's also, thank you, Sumit, for answering. We do have sample Grafana dashboards where you can add Prometheus as a data source. Each of the, for your basic performance counters, each of the tablet servers and master processes do export a Prometheus endpoint for lots of metrics. In fact, those are the endpoints that the YBstats tool that Frits has built is also using as one of its input sources. And then the YugabyteDB Anywhere, which is Yugabyte's sort of control plane and manageability layer, that's not part of the open source offering. That also has a rich metrics component where there's a lot of graphing and demos. I don't know if you have a cluster handy, Frits, where you could just take 30 seconds to give a feel for the metrics dashboard. If you don't, it's fine.
No, I'm using a different computer. That's actually on the computer on the right-hand side, for which.
No worry. So maybe that's a topic for another day.
Yeah.
But let me just check if there are any other questions. Thank you so much, Frits, for building the tool. It's already been used quite a bit by users as well as our own team and our support team when investigating performance issues or bottlenecks. Over to you for closing thoughts and to wrap up today's presentation.
Yes, indeed. Thank you. Well, like you said, these statistics are the basis of what is in Yugabyte statistics, and these are exported to these Heaven Prometheus endpoint and are can be concentrated there, for which you can show graphics. These serve a different function, and YBstats also obtains the log files, for example, of all the individual daemons which are running, which allows you to investigate that. So this serves a slightly different function in that sense. And the aim is to just get all this data in that sense and make it transportable. Prometheus data is notoriously hard to transport in that sense. So these are the closing thoughts on that. I do not have a screen in which I can see the question, so I'm depending on you guys for that. But
yeah. I think I relayed the questions that came through. Thank you very much. Have a good day, good weekend, and see you next Friday.
Okay.
Another episode of Friday Tech Talks.
Okay. Thank you everybody for joining, and thank you for watching. Goodbye.